How Intel turned environmental constraints into a planning advantage. Across U.S. industry, environmental constraints are increasingly surfacing as execution risks rather than compliance formalities. Water scarcity, air permitting, chemical controls, and inspection intensity are no longer peripheral considerations for large facilities. They are shaping where projects can proceed, how quickly capital can be deployed, and whether long-term operating certainty can be maintained. Intel's recent U.S. manufacturing expansion offers a clear counterexample to the growing operational friction many companies are experiencing. Rather than treating environmental and regulatory limits as downstream hurdles, Intel integrated them into early planning, governance, and capital sequencing, turning constraint management into a stabilizing force. This is not a sustainability branding story. It is a case study in environmental and legal discipline as an execution strategy. Designing for scrutiny, not speed. Semiconductor fabrication is among the most resource and regulation-intensive forms of industrial manufacturing. Fabs require ultra-reliable power, massive volumes of high-purity water, advanced air controls, and constant oversight from environmental and safety regulators. For many manufacturers, those requirements collide with construction schedules late in the project lifecycle, when delays are most expensive. Intel approached that risk differently. According to its 2024 to 2025 corporate responsibility disclosures, the company operated under 218 regulatory agency inspections globally in a single year, including environmental, health and safety, and fire protection authorities. Despite that level of scrutiny, Intel reported no fines and no significant non-monetary sanctions related to environmental or safety non-compliance. That outcome reflects a core assumption embedded in Intel's facilities strategy. Regulatory oversight is not episodic, it is continuous. Planning for constant scrutiny, rather than ideal conditions, reduces the likelihood that environmental or legal issues emerge late and disrupt execution. Water risk elevated from ESG metric to continuity constraint. Water has become one of the most legally and politically sensitive constraints facing advanced manufacturing, particularly in the U.S. Southwest. Intel operates major fabrication facilities in regions classified as high or extremely high water stress, including Arizona. Instead of relying solely on efficiency gains, Intel positioned water availability as a continuity and permitting risk. In 2024, the company conserved and restored approximately 13.4 billion gallons of water, maintaining net positive water status in the United States and several other countries. From a legal and regulatory perspective, this posture matters. Water scarcity increasingly fuels permit challenges, community opposition, and litigation risk. Operating with a surplus water profile in stressed regions reduces exposure to future withdrawal limits and regulatory tightening, an advantage that only becomes more valuable as competition for water intensifies. Environmental compliance. Embedded in capital governance. Intel's approach is reinforced structurally. All of its global manufacturing sites maintain ISO 14001 environmental management certification, and all manufacturing operations are certified to ISO 5001 for energy management, a level of consistency uncommon across large industrial portfolios. Environmental performance is also tied directly to financial governance. In 2024, Intel linked executive and employee compensation to metrics including renewable electricity use, greenhouse gas reductions, water conservation, and waste diversion. The company reached 98% renewable electricity globally and reduced Scope 1 and 2 emissions by 29,000 metric tons of CO2e during the year. This alignment matters because it limits internal friction. When environmental risk influences compensation, financing, and capital approval, not just reporting, compliance decisions are less likely to be deferred or overridden during execution. Chemical and air controls, treated as engineering inputs, air permitting, and chemical management are among the most common sources of late-stage delay in advanced manufacturing projects. Intel's disclosures show a different posture. Emissions controls, hazardous air pollutant management, and chemical substitution policies are treated as design constraints, not compliance afterthoughts. The company maintains restricted substances lists, requires full chemical disclosure from suppliers, and applies site-specific controls for pollutants such as nitrogen oxides, volatile organic compounds, and particulate matter. This approach shortens regulatory review cycles by reducing uncertainty during permitting and inspection processes. As Intel has framed its manufacturing philosophy in public materials, controlling environmental risk upstream provides greater predictability downstream, a critical advantage when projects involve billions in fixed capital. Managing operational friction by eliminating assumptions. Intel did not remove environmental constraints from its planning environment. Instead, it eliminated assumptions that those constraints could be resolved later. By aligning environmental readiness with capital sequencing, rather than treating it as a parallel track, the company reduced second-order operational friction, stop-start construction, redesigns driven by permit conditions, and legal exposure tied to community or regulator intervention. The result is not faster execution at all costs. It is more reliable execution with fewer surprises embedded in long-term manufacturing plans. What this signals for 2026 facilities and compliance strategy. Intel's experience illustrates a broader shift underway across capital-intensive industries. Environmental and legal constraints are increasingly determinants of feasibility, not background conditions. Water, air, and chemical controls now shape site viability as much as labor or power access. Companies planning for ideal execution are more exposed to delay and dispute than those planning for constraint. In 2026, operational friction is less about mechanical failure than misalignment between planning assumptions and environmental reality. Intel's model shows that when constraints are acknowledged early and governed rigorously, they can reduce volatility rather than create it. You've been listening to Sustainability Soundbites by Environment and Energy Leader. For partnership opportunities, please reach out to our team.